For this lesson, we're going to explore the various primitive data types used in C. We've seen one of them in the previous lesson, which was an integer, and we declared two variables in two different ways. One was by declaring it and then assigning a value to it, and then the other one was we assigned the value at the moment we declared it. We call that initialization. So now we have a new file, and I'm writing it right now, var example2. So let me save that in the same directory. And what I also did in this file is I actually wrote the comment block. This is called a comment block, where instead of writing comment line for line, this allows me to write several lines within the same or encapsulated within the same symbols that you're seeing here. Slash star, star slash, so you only need these two. Now, this is a good place to put some comments, some documentation as to what your source code is supposed to do. So in our case, it's a lesson, so we write down the lesson objective is to explore the various primitive data types used in C. Now you would say, what do we mean by primitive? That means these are part of the language. They're not user-defined, so they're not special. That you didn't create them yourself as the programmer. And so they're inherently within the language itself. Okay, so what does C allow us to have? Well, we've seen an integer, right? So what about, and I mentioned something about float numbers. Well, then if you need a decimal point, you need some precision in your numbers, or you need to express your numbers with a decimal point, right? No commas. So what's going to happen is you're going to need a float value. How about characters? Then you're going to need a char data type, etc. So let's go ahead and explore all of these. What I'm going to do here is declare variables of different data types. And then what I'm going to do is assign values. So as you can see, I'm strategically positioning some comments. What is it I'm going to do exactly with my code? And in here, I'm going to assign values for the variables. Lastly, I'm going to print the content of the variables. Okay, so I have three strategic areas within my source code that I need to handle. Well, remember, if you wanted a number of integer type, you could have set something like this, int, and then you can name your variable whatever you want, as long as you use lowercase to start. So don't start with uppercase, even though it's not going to matter, but it's a convention. However, you can't start with a number. That would be wrong. So, or a special character like this. Do not do that. So if you want something like this, num1, absolutely. So if I put a semicolon here, that's one variable of type integer. Can I have more of type integer? Yes, and you can separate them with a comma. You could write a comma, num2. So now I have two variables of type integer, uninitialized, which means they don't have any values in them. So they're basically two spaces reserved in memory for num1 and num2. At runtime, when you run this program, that's the first thing your program will do. So let me compile and run here. And you're not going to see anything because I don't have any outputs other than press any key to continue. But while your program ran, two spaces, one for num1 and one for num2, were reserved. But no alteration was done to the content within those two memory locations. Okay. Now, how about a different data type other than integers? Remember float? I mentioned something about float. Yes. So floats will be used for numbers that would have a decimal point, right? Real numbers, right? So that would be like, let's say, num3. Okay. So these will be integer type. And these here will be float type. Can I have more than one float type? Absolutely. And if you want to write them on the same line, just put a comma just like you did with integer. Okay, fantastic. So what else? Can we have char? Yeah, so char, my letter. And notice you can name your variable something a little more meaningful. What is it you're going to store in there? A letter, right? So semicolon. And that would be a character type. Okay? So let's focus on these three. And that what's going to happen is eventually within int, for example, and within float, we have subcategories depending on how many bytes you really need. So sometimes because int only has by itself has 4 bytes, and if you're going to handle really long numbers, large numbers that will require more than 4 bytes, right? 4 times 8 bits, then you're going to need a special category, and that would be like a long int. Okay, well that's for another lesson. Right now, let's just focus on these 3 primitive data types, and then we'll look at the categories like short and long. So how can I use them? How can I assign values to these? Well, right now, we're going to write the values or assign the values in the source code itself. So we're not making this program interactive yet. So something like this, num1 could be equal to 8. Num2 could be equal to -5. And then each one its own line. Num3 will be equal to -7.8. Okay? And how about my letter? And that would be, notice how you give a value, you put a single quote, and then put the character that you want. Let's say uppercase H. That's fine. Then close the quote and then put a semicolon. Okay. Now, every time you finish a block of code like this, it's a good idea to just compile. And the reason I'm compiling, not only I'm turning it into an application, but it's checking for syntax error for me. Right? Good. Now I'm ready to print. So we're going to write a print statement for each one of them or for a few of them. So I'm going to print the 2 integers together in the same line. So printf. And I'm going to write this. Num1 equals %d. And I'm going to put a comma here and a space. Num2 equals. So you can format the output. And notice I have 2 placeholders, %d and %d, which means, and I'm going to put a /n. Remember that one from the previous video? Fantastic. So now I'm going to put num1, comma, num2. Notice the number of arguments has increased based on what is it I'm handling. I'm handling num1, that's going to go right here. And I'm going to handle num2, that's going to go to the second placeholder right here. Okay? And now let's go ahead and do the float one. Now notice with integers you do %d. Now let's see how we handle float. Printf. And then we're going to do the same thing. Num3. Okay? %f allows you to print a float. Let me put a /n since we're only printing one value there. And that would be num3. Okay? How about the letter? Sure. So we could do printf. And then my letter equals, now watch what I'm doing here, %c, /n. Give me a new line. %c is for a character. /n is an escape character that allows me to get a new line. And my letter. Okay, now let's see what results we get out of this. Compile and run. And here they are. So notice the formatting of the output. I wanted num1 and num2 to be on the same line. Num1 equal 8, num2 equal -5. I wanted num3 to be in a separate one. And notice by default, the precision set right here, 7.8000000. That's a lot of precision for just entering a number like -7.8. Can we adjust the precision? Absolutely. We'll do that in the next video or the next lesson. We will format these a little better. How about my letter? Yeah, so we can look at what's stored in my letter. And by the way, you would ask how many bytes any of these will take in memory. We will have a lesson on that. We're going to see that my letter actually takes a single byte, which is 8 bits.